To understand, we need to refine our model of how the CPU is working with memory. The idea that the minion steps through these instructions is basically right until we get to an instruction that reads or writes memory. In that case, the minion has to go run off to where memory is stored and get values out of that memory and bring it back to the CPU to work with. But it doesn't actually just run to memory and then straight back. Instead, there is a cache involved with the CPU and the memory system. So the minion doesn't run off to memory when it sees an address, it first runs off to the cache to see if something is there. If the value is not cached, then the minion has to run out to memory, grab the value that's there, and move it to the cache. And so the slots in memory are more like shoeboxes, where the minion fetches the shoebox, moves it to the cache where it can be found quickly, and now the minion can get or put values in the shoebox, and eventually when the cache gets too full, the shoebox can be returned back to main memory. So, the minion is going to check a cache every time, and if a value is in the cache, it'll be much faster to get the value there than having to run out to main memory. We're interested here in the L1 cache, which is the one that is closest to the CPU, and that usually holds on the order of 100,000 bytes. That's why my big array was much bigger than the L1 cache. Indirectly then, we can find out whether an address in memory was used recently. If it was used recently, then it'll be in the cache, and a minion won't have to run all the way out to main memory, it'll just have to run to the cache to get the value. And that explains the difference between my small array and big array programs. Because the program is jumping around in the array, the small array completely fits in cache, and so the minion never has to go out to main memory. With the big array, the minion is having to go out to memory as often as not, and so the program becomes much slower. The time difference that we see between the big and small arrays is pretty much the time difference between fetching memory from the L1 cache and fetching it from main memory. So far, so good. There's nothing necessarily wrong about taking longer to read some memory than others, and it's a key part of modern architecture to make programs run fast to have a cache instead of always fetching values from main memory.